we'll discuss the crystal lattice now. We have discussed about the various types of crystal solids, right? Now let's go deep into the crystal and understand the crystal lattice, how the crystals are formed. So we have seen that the main feature of crystalline solid is the regular and the repeating pattern of constituent particles. Correct? That's what we have heard so many times. The crystalline solid, that means regular and repeating pattern of constituent particles. So if you see the regular 3D arrangement of point in space is called crystal lattice. Let me write this. So what is crystal lattice? It is nothing but a regular 3D arrangement of points in space. So if you see, this is a 3D arrangement of NaCl, right? This is also 3D arrangement of silicon. This is also 3D arrangement of carbon, graphite. So if you see, these are all 3D arrangement. This is 3D arrangement of Na plus Cl minus. So these 3D arrangement is called crystal lattice. We'll tell that this is the crystal lattice of sodium chloride. This is the crystal lattice of carbon. This is the crystal lattice of silicon. So crystal lattice is also called periodic and systematic arrangement of atoms found in crystal. Correct? Please note, it is not found in amorphous. Amorphous solids or gas, you don't have crystal lattice, because crystal lattice, it has to be regular. You see the regular word is there. So regular word doesn't come in amorphous. Correct? So crystal lattice, regular 3D arrangement of points in space. So why we are studying crystal lattice? Good question. The physical properties we have discussed now, the malleability, ductility, or various other physical properties, the electrical conductivity. So those things actually depends on this crystal lattice. Till now we discussed about melting point, boiling point on the very high view. But actually, if you want to understand deep for a given compound, why this compound behaves in XYZ manners, you have to understand the crystal lattice. It is very, very critical, because this crystal lattice explains the physical properties of a crystal. Correct? So, since crystal lattice is very critical to us, let's understand some of the properties or characteristics of the crystal lattice points. See, this crystal lattice, each point in this crystal lattice is called lattice point. So you see, these are all lattice points, right? Or lattice sites. Each point in this crystal lattice, it represents one of the constituent particles. It may be atom, molecules, or ions. For example, in this case, this is my Na plus ions. It is my Cl minus ions. So each of these points will represent a constituent particle. Correct? So each point is called lattice point or lattice site, and each of these lattice sites is nothing but a constituent particle. And these lattice points are joined together. For example, this and this point, they'll be joined together by a line. And why it is done? Just to give a geometry to this lattice. Just to give, it doesn't make much sense. They are all virtual lines, they don't exist actually. If you see a particular compound in using X-ray diffraction techniques, you won't see any lines. They are just joined to give out a geometry to this lattice to just understand it better. Correct? Now let's talk about unit cells. This lattice itself, you see a big lattice, right? Difficult to understand, understand the concept. So this lattice is further divided into unit cells. Unit cells are the building block actually. So what are unit cells? So unit cell is the smallest portion of crystal lattice, which when repeated generates entire lattice. For example, this you get from this. So if you see, for example, if I want to draw So if you take this portion out, you'll get this. So these are my sodium, and this is my chlorine. Correct. So chlorine occupies this corner place, and these are the spaces, voids. Sodium occupies this. So this is my unit cell. Correct. This is the smallest portion, because this itself, you keep repeating it, you will get the lattice. So lattice is a bigger picture. Correct. But the unit cell is the building block of the lattice, because you keep repeating this unit cell, you will get the entire lattice. So understand, the lattice is a bigger picture. Whenever I talk about this is my lattice, it has so many unit cells, and unit cell is the basic building block, smallest portion of the crystal. Correct. So if you want to see in this figure, you can see in this three-dimensional view and more view, where we have, these are my chlorine. Since the sodium is in the voids, the empty space, I have not shown sodium here, but sodium will be somewhere here and here, like that. Correct. Both the pictures are same actually. We'll take you through a video where you understand all these shapes in a better way. Now let's understand some characteristic of unit cells. So its dimensions it has three dimensions. It has three edges, A, B, C, and these edges may or may not be perpendicular. And the angle between the edges is alpha, beta, and gamma. So if you see, this is my unit cell. It will have normally cube or cuboid or hexagonal shapes, the three-dimensional shape. It has three edges, A, B, and C. These edges may be equal, may not be equal, may be perpendicular, may not be perpendicular, right? And the angle is alpha, beta, gamma. So if you see, alpha is the angle between B and C. So alpha is the angle between B and C. Beta is the angle between A and C. And gamma is the angle between B and C. Correct? So alpha, remove the A, you get BC. Beta, remove B, you get A and C. The remaining one is gamma. And these angles, so to define the unit cell, you need 6 parameters. Hope I understand. Because if you make A, B and C equal and alpha, beta, gamma 90 degree, you will get what? You will get a cuboid. Correct? You will get a cube actually, where A, B, C are equal and alpha, beta, gamma is 90. And you say A is not equal to B is not equal to C, but alpha, beta, gamma are equal and they are 90 degree. Then you will get cuboid, something like this. Correct? So based on, by changing these parameters, right, A, B and C and alpha, beta, gamma, you will get different types of unit cells. Correct? So unit cells are the basic building of lattice. Unit cells is nothing but a three-dimensional box kind of thing. Correct? It is either cube, cuboid, there are various unit cells, and the parameters for unit cells is alpha, beta, gamma, A, B and C. A, B, C are the lengths of this unit cell, alpha, beta, gamma are the angles. So they are very